pyranometer. Pyranometer for measuring solar radiation. Leveling point. Adjustable screw. You see the level of actual photo of pyranometer. Installation of pyranometer. Leveling point by adjustable screw. This is adjustable screw. Exact level. Exact level. Pyrheliometer is we are studying in this lecture. So we start with pyrheliometer. This is the diagram of pyrheliometer. We see the parts of pyrheliometer. This is the acceptance angle in which solar radiation is received. If any radiation is out of this area, it is not counted. So in this area, it is not counted. Next is glass window, which concentrate the solar radiation on hot plate or a blackened plate. Next one is tube, and last is thermopile, which is the junction of black surface and electric wiring. So we start working of pyrheliometer. It is an instrument which measure beam radiation. The black absorber plate, here is the black absorber plate. Black absorber plate is located at the base of tube. The tube align along the direction of the sun rays with the help of two-axis tracking mechanism and alignment indicator. With the help of alignment indicator and two-axis tracking system. The direction of sun rays is received at the black surface or black body. The black disk absorbs only beam radiation and a small amount of diffuse radiation falling within the acceptance angle of the instrument. Now, this is the inner parts of pyrheliometer. This is black body. This is black body which absorbs the solar radiation, and it is joined with the electrical system where electromotive force EMF is produced, and it is counted by voltmeter. In this instrument 0 to 10 millivolt EMF is produced, which is we read and record by this voltmeter. Actual photos of pyrheliometer. We complete our three solar radiation measuring instruments. Number one is sunshine recorder, number two is pyranometer, and number three is pyrheliometer. Now we see our next topic, device for solar thermal collection and storage. Solar thermal collection and storage, we studying according to our syllabus three types of instruments. Number one is flat plate collector, FPC. Number two is cylindrical parabolic collector, CPC. Number three is paraboloid concentrating collector, PCC. So, in this lecture, we studying flat plate collector, and remaining two, CPC and PCC, will be in next lecture. So, we start with FPC, flat plate collector. This is the block diagram or figure of flat plate collector. In a collection device, the principle usually followed to expose to dark surface to solar radiation so that the radiation is absorbed and is then transferred to a fluid like air, water, or any oil when no optical concentration is done. The device in which collection achieved is called flat plate collector. We see here there is a two transparent screens which are made of glass, transparent screen, and after transparent screen the surface is blackout. Black absorber plate is there and the fluid is passing in the tube. Flat plate collectors basically consist of an absorber plate on which solar radiation falls are coming from one or more transparent cover, usually a glass covers. Absorbed radiation is partly transferred to a liquid flowing through the tubes which are fixed to the absorber plate or are integral with it. This energy transfer is useful gain. Some part of radiation is lost by convection and radiation. Transparent covers help in reducing convection losses, while thermal insulation helps in reducing losses by conduction. Water is used as the working fluid in the flat plate collector. Flat plate collectors are usually seated in fixed position on supporting structure facing south. This is the detailed diagram of flat plate collector. We see the advantages of flat plate collector. It is simple in design. No moving parts, require less maintenance, can be used for variety of application in which temperature ranges from 40 to 100 degrees Celsius. We have some videos of this flat plate collector. It is attached here. Please show. Flat plate collector. Absorber plate. Cold water is flowing and converted into hot water. In thermal application, in last lecture we studied flat plate collector. Now in this lecture we studying CPC, cylindrical parabolic collector. You see the main parts of CPC: central heat pipe, parabolic shape reflective collector or reflective coating or mirror, and collector supports. We see the construction and working. When temperature exceeding 100 degrees Celsius are required to be achieved by cylindrical parabolic collector. It is noted that if we have exceeding temperature below 100 degrees Celsius, then or 40 to 100 degrees Celsius, then we use flat plate collector. And if above 100 degrees Celsius, so that is this instrument CPC is used. And if we exceeding above 400 degrees Celsius, then next our instrument paraboloid concentrating collector is required. So it is used for the temperature range 100 to 400 degrees Celsius. It consists of a concentrator and a receiver. The concentrator shown in mirror reflector having the shape of cylindrical parabolia. this is noted that the shape of receiver shape is cylindrical parabolium. It focuses sunlight on its axis where it is absorbed on surface of absorber tube and transferred to the fluid concentric glass cover help in reducing convective and radiative losses to the surrounding in order that sun rays should always be focused onto the absorber tube. The concentrator has to be rotated. This method is called tracking. So this is the working of cylindrical parabolic collector. This is the side picture of or actual picture of CPC. Actual photos of CPC, and many CPC are together each other. I have some videos of this cylindrical parabolic collector. It is attached here. Solar radiation absorbed at concentrated and then they absorb on receiver. Parabolic concentrating collector. Sun field. Construction. Shape of this instrument. Cylindrical parabolic. This type of solar radiation is received at concentrator and absorbed at receiver. Fluid in passing inside the tube, which heats up the fluid. Fluid is passing inside the tube continuously. Cylindrical parabolic concentrating collector. Two axis tracking system. It is move with movement of sun and solar radiation. From this system, the sun is in line with focus. our next and last instrument for thermal application and storage, paraboloid concentrating collector, PCC. Paraboloid concentrating collector. We see the main parts of this PCC: receiver, declination axis, concentrator, declination drive, jack screw, supporting base, polar axis, polar device, jack screw, and counterweight for the better result. We see the some other photos of PCC. It is actual photo of paraboloid concentrating collector. Now we see the working of paraboloid concentrating collector. We discuss above when temperature attainable above 400 degrees Celsius, then paraboloid concentrating collector should be selected. It consists of a receiver and concentrator. The paraboloid concentrating collector is costly and therefore used for special purpose and having a supporting structure, polar axis and declination axis. These collectors are used where temperature about 400 degrees Celsius are required. This collector requires two axis tracking system so that sun is in line with focus and the vortex of the paraboloid. I have some videos of this instrument which is attached at here. Paraboloid concentrating collector. Sun rays is focused on paraboloid receiver. Here collector requires two axis tracking system so that sun is in the line with focus and the vortex of the paraboloid shape. Thermal application of solar energy. This is the last point of our this unit. Thermal application of solar energy. We see thermal application in following parts: water heating, space heating, power generation, space cooling and refrigeration, distillation, drying and cooking. In this lecture, we studying only water heating. Remaining 6 are in next lecture. So, we start with water heating. Thermal application of solar energy as a water heating. Water heating system. We first studied thermosiphon type water heating system. Figure shows thermosiphon type natural circulation type water heating system. The diagram of a simple small capacity natural circulation system is shown in figure. As a water is heated by solar radiation, if flowed to the top of water tank and in replaced by cold water from the bottom of the tank. Hot water for use is withdrawn from the top of the tank. When this is done, cold water automatically flow from the bottom of the tank. An auxiliary heater is sometimes arranged in the system for cloudy or rainy days. Solar water heaters have an install cost of rupees 100 per liters and temperature of hot water delivered is 50 to 60 degrees Celsius. The capacity of such water heaters ranges from 100 to 200 liters per day. This is the second diagram of this simple thermosiphon type water heating system. Now, next instrument for water heater is collector cum solar type water heater. Figure shows collector cum solar type water heater. Small capacity domestic solar water heaters are also available in simple design. It consists of a shallow rectangular box of 5 cm to 10 cm deep made up of steel. The boxes contain in housing which supports the glass cover and is insulated from the bottom and sides. The box is filled up with water in the morning which is heats up during daytime and can be used water. The advantages are it is less costly than the natural circulation type, that is we see above is thermosiphon type. It is less efficient and yields lower temperature. This is the second figure of collector cum solar type water heater. Now industrial solar water heating system. We studying two types of industrial solar water heating system. One is closed loop and second is open loop. So first of all we studied closed loop industrial solar water heating system. More than one collector when used, it is called array. In figure, we show one, but more than one collector, flat plate collectors are required. So, more than one collector when used, it is called array. This type of system are used where large quantity of hot water is required and there is a restriction that storage tank should not be at higher level is thus removed. Water is heated in array which is pumped through a pump and flow back to storage tank. Hot water is used for use and cold water takes its place because of ball control foot valve. The pump is used for maintaining force circulation which is operated by on off controller which since the temperature of water at exit of the collector and pump is switched on when there is a variation in temperature. There is also a provision of auxiliary heaters as shown in the figure. This system is suitable for factories, hospitals, hotels and offices. This system cost is about rupees 5,000 per square meter of the collector area. This is the other figure of closed loop configuration. And last, industrial solar water heating system and open loop configuration. In open loop, the transfer fluid is cold water to a hot water. Cold water to a hot water. Auxiliary heaters is not necessary in open loop solar water heating system. But sometimes in rainy days or cloudy days or in cooler days, auxiliary heater works. A hot water can be stored in hot water storage tank. When required, it is pumped at a required place. Some videos of water heating system are attached here. Please see the videos. Water heating system, storage tank and flat plate collector. Tank is connected with flat plate collector. These all are connecting pipes. Solar radiation is absorbed on these pipes, absorber pipe, and water is heated inside the pipe. Surface of pipe is blackened. When water is passed from this pipe, they absorb solar radiation, gain temperature, and as a result, hot water is out. In storage tank, from the principle of physics, hot water is above the cold water. So, in tank, at a bottom, cold water, and at a top part, hot water is there. Solar water heating system. Whole day solar radiation absorbed on flat plate collector. Then hot water go to storage tank. Continuously cold water is replaced by hot water. Industrial solar water heating system or a commercially large quantity of hot water is required, then set this type of collectors. More than one flat plate collector is attached, it is known as array. This type of storage tank is required in commercial use. Whole day solar radiation absorb cold water from tank is flow up in array and it is heated and hot water is stored in storage tank. And when we require hot water, it flow from our required place. Continuously cold water is takes place and hot water is out. Take care of you and your family. Thank you.